Hello everyone, am I audible to all of you? Hello, hello, hello.
Yes, sir. Yes, sir.
Okay. বাকীবিলাকে কিয় ৰেছপণ্ড নকৰে কেতিয়াও? No, why doesn't other respond? I'll mark everyone absent if they doesn't respond. So today we will be going to start a new topic, which is D'Alembert's principle. So before starting the topic, in order to clear the basic concepts, so can you see the notes? D'Alembert principle is also known as the Lagrange-D'Alembert principle and is a statement of the fundamental classical laws of motion. Okay. So it is named after the French physicist and mathematician Jean-Le-Rond D'Alembert. It is a dynamic analog to the principle of virtual work for applied forces in a static system. And D'Alembert principle are you able to see the PDF?
No, sir, no.
No, no.
We
Wait, wait,
can't.
wait, wait, wait. I'm having some problems. So D'Alembert principle basically states that if a rigid body is acted upon by a system of forces, then this system may be reduced to a single resultant force, whose magnitude, direction, and line of action may be found out by the method of graphic statics. So we all know that F equal to ma, right? So if F equal to ma, then m is the mass of the body, right? M a is the acceleration of the body. So we can write as F minus ma equal to 0. So this equation is basically known as the D'Alembert's principle. So here, if you see here, from Newton's second law of motion, we know that F equal to ma. Now this F equal to ma can be written as F minus ma is equal to what? 0. This minus ma means what? It can be written in this manner, F plus minus ma. So this force minus ma is called inertial force. Therefore, the vector summation of the applied force, that means what? This thing, this part, is what? 0. So this thing is called basically what? D'Alembert's principle. So this thing is known as what? D'Alembert's principle. So the basic philosophy behind this is that the problem of dynamic equilibrium is converted to problem of static equilibrium. So basically, in D'Alembert principle, this thing only exists. Okay. So after that, we'll solve certain numericals from the next class. So if you can see, there is another term called principle of conservation of what? Energy. That means principle of conservation of energy. This thing. So as per principle of conservation of energy, it means that the energy can neither be created nor be what? Destroyed. This is the principle of conservation of energy. That means energy can neither be created nor it can be what? Destroyed. That means what? The total energy of the system, it remains constant. So if you are asked to write what is the principle of conservation of energy, then you have to write these things. Okay. energy can neither be created nor be destroyed, but energy can be converted from one form to other form.
Hello.
हाँ बोलो.
Sir,
हाँ.
can you elaborate the Allenborg's principle with an example, practical one?
एग्जाम्पल कुछ नहीं है. देखो, we applying force somewhere in a body, right? So this is what F. F is the force, right? Now force can be defined as the what? This is the mass. So
Into
this is
acceleration.
so and there may be certain amount of acceleration here. A. Yes or no? Now
Yes,
look.
sir.
So we all know F equal to what?
Into acceleration.
So F equal to what? M A. Yes or no? So if F equal to M A, then we can write this as like this: F minus M A is equal to what? 0. You can write this as like this or not?
Uh,
Hmm? So this thing
yes, sir.
F minus M A can be written as like this now. F plus minus M A. Yes or no? Yes or no?
Sir.
So this comes out to be what? Now F is what? A vector quantity always. The force is a vector one because it has a magnitude y vector because F has what? Both magnitude and direction, right? From next class onwards, we'll be solving certain numericals on this. Then you will be understanding it more properly. Direction, no? Yes or no? So since F has both magnitude and direction, that is why here F and similarly A. If we similarly what A also has what both magnitude and direction, right? Now if A also has both magnitude and direction, so we can give one. Please mute your mic. So we can write in this manner or in this manner. So this minus MA, hmm, this minus MA thing is called what? Inertial force. And the vector summation of the applied force is 0. So that means what? This part, this part is 0, no?
Sir. Sir, it means that opposite force is applied with
ना
an
ना.
equal amount of.
हाँ अपोजिट ही होगा. मतलब क्या होता है? अपोजिट फोर्स नहीं होगा. मतलब डायरेक्शन का बात छोड़ो तुम. सिर्फ कॉन्सेप्ट को याद रखो, एफ माइनस एम ए इक्वल टू 0, समझा? क्योंकि एफ इक्वल टू एम ए होता है, यू नो ना, एफ इक्वल टू एम ए, राइट? तो
ओके, ठीक है सर।
एफ इक्वल टू एम ए होता है, तो इफ एफ इक्वल टू एम ए, देन हाँ then bring the fa ma this side, hmm, and eventually what, you can write it as f minus ma now, so this will be equal to what, 0, right? That's it. Clear? Is it clear now?
It's clear.
So in this way we can explain D'Alembert's principle. Now after D'Alembert's principle we are having what, principle of conservation of energy. So principle of conservation of energy means what, energy can neither be created nor be destroyed, but energy can be converted from one form to other form. Okay, this is what the basic principle of conservation of energy. Now after that it is what, power. Power is what, rate of doing work. So rate of doing work is what, power. So we discussed power in the previous classes also. So it is defined as the what, time rate of doing work, right? Now after that, efficiency. Efficiency is defined as the ratio of output energy to input energy. That means what? Suppose energy is inputted. Energy is inputted means what? Suppose a machine is there. Hmm. So how will be the energy inputted for doing work? It will be like in the form of fuel. Fuel will help in developing the energy. So that is the input, and the output energy is what? The purpose for which that machine is used. Yeah. So the purpose for which the machine is used, that is the output. Now, but ratio of output to input. Remember, it is output to input, okay, not input to output. That ratio is basically known as what? The efficiency of the machine. Okay? Is it clear up to this?
Sure. More efficiency will have more output.
अगर ज़्यादा efficiency होगा तो ज़्यादा output होगा ना, ठीक है? हाँ, you are
Okay,
right,
okay.
you are correct. Okay? अगर डाउट है किसी का तो पूछो तो. If someone has any doubt, you can ask me.
Can you see the screen? Can you see the screen?
Yes, sir.
To the session of engineering mechanics.
So just try to understand this. It will clear the concepts more.
In this session, we will try to understand one of the important principle of dynamics, that is D'Alembert's principle. D'Alembert's principle is nothing but it is an alternative form of Newton's law of motion, which helps to write the equation of motion for dynamic system. Basically, what we do, we add a virtual force on the dynamic system so that we can write equation of motion for the dynamic system by considering it as a static system. To understand this, let's consider a problem where we are having a mass m and four different forces F1, F2, F3 and F4 are acting on mass m1 or m, and because of all these forces the system is not moving. Let's consider the first case where the system is stationary, and if the system is stationary we can write the equation for the static equilibrium, which says that the total force acting on the system will be zero, or the sum of all the forces will be zero. We can write this in two ways. We can write all the horizontal forces will be zero and summation of all the vertical forces will be zero, or we can write the vector equation where the four forces will be the summation of the four forces will be zero. Now let's consider the second case where we assume that because of all the four forces the system is moving, or we can say that the summation of all the forces is not zero, and if the forces will not be equalize each other, there will be a resultant force on the system which will try to move the system with certain acceleration. So now we are having a system where the four forces are not balancing each other, and because of that there will be resultant acceleration A, and system is moving. So now from the Newton's law we can say that all the forces will be equal to a value mass into the acceleration. So based on this philosophy, D'Alembert principle says that okay, you are having four forces, and because of the four forces the system is moving, so let's make the system static by adding a virtual force of a magnitude m into a. So please understand what we are doing. We were having four forces, and because of the four forces the system is moving with certain acceleration a, and now what we are doing, we are adding an additional force of magnitude ma, and because of this ma, now the system will be considered as an equivalent static system. And now if I will write the equation for this static system which is actually moving, but I have considered this system an equivalent static system, the total forces minus mass into acceleration quantity will become zero. So let's summarize the principle that what we are having a system where four forces are acting on the system, and because of the four forces the system is moving with certain acceleration a. Now what we have done,
create videos for your business with hundreds of templates designed to get them performing their best with Vimeo Create.
based on the principle the D'Alembert principle, we have added an additional force, and because of the additional force now the system has become an equivalent stationary system, and now I am writing its equation of motion by considering it as a static system. So the summation of all the forces along with the additional force will be zero. So basically the D'Alembert principle helps to write the equation of motion of a dynamic system by considering a virtual force, and this virtual force is nothing but is known as the inertial force. So now let's take one example, a very simple example where we are having three masses connected with the strings, and this two strings are inextensible. That means the length of the string will not change due to the force, and we are having a force F, and because of the force F the system is moving with acceleration A. There will be tension in the string named by T1 and T2, and we have to find the tension in terms of mass, acceleration and force. So what we can do, first we have to make the free body diagram of three systems or three masses. For mass M3, there will be only one tension, so T2 will be the force and the system is moving with acceleration A. For the second mass, I will be having tension T1 acting towards the right and tension T2 acting towards the left, and the system is moving with acceleration A. Similarly, for the third mass, there will be force F and tension T1. So now we have to write equation of motion for the three masses. So let's assume, or let's consider one convention, that what we will do, we will consider that the direction of motion will be positive. That means what we will do, we will consider all the forces acting in the direction of motion will be positive, and then we will write the equation. For example, I want to write the equation for the third mass. As the mass is moving in this direction, this will be my positive direction, and for this, so that the F will be positive, T1 will be negative, and these two will be equal to the mass into acceleration. Basically what we are doing, we are taking mass M3, and these two forces are there on mass M3. Now what we will do, we will consider an additional virtual inertial force which will make the dynamic system as an equivalent static system, and now I am writing the equation for this system. So we can say that this F1 minus T1 will be balanced by M3A. Similarly, I can write the equation for the second mass, where this is the direction of motion, so T1 will be positive, T2 will be negative, and these two will be balanced by M2A. Similarly, for the first, there is only one force, so T2, that is in positive direction because the mass is moving in this direction, will be balanced by M3A. So please recollect all these things. That's what we have done. We have assumed that this direction of motion will be positive, so all the forces acting in this direction will be considered positive. T1 will be acting in opposite to the direction of motion, so it will be negative, and this will be my equation of motion. Now let's take another problem where we are having a pulley, and the two masses M1 and M2 are suspended through the inextensible string, and there will be tension T because there is no friction in the pulley, so tension at the both sides of the pulley will be same T and T. And let's assume that the mass M1 is more than M2, so that the total system will move, that M1 will go in the downward direction and M2 will go in the upward direction, and we have to find the acceleration or tension. So first what we will do, we will make the free body diagram. Let for mass M1, the mass is moving in the downward direction, there will be a gravitational force acting in the downward direction M1G, and a tension force T in the upward direction. Similarly for M2, the M2 is moving in the upward direction, acceleration will be in the upward direction, and the tension and M2G. If I will write the equation of motion considering the D'Alembert principle, the direction of motion will be positive, so M1G will be positive, T will be negative. So my equation will be M1G minus T, and that will be balanced by M1A. Similarly, in the second case, the mass is moving in the upward direction, so T will be positive and M2G will be negative, so T minus M2G is equal to M2A. Now let's take a numerical problem where we are having two masses MM connected with a pulley, and now I am putting an additional mass of small m, and because of the small m the total weight at the right hand side will be higher, and because of that the system will move so such that these combined masses will go in the downward direction, and the mass at the opposite side will go in.
So better we'll discuss the example after we solve some numericals. Okay. So if you have any doubts, you can ask me.
No, sir.
Sorry.